So it's been very exciting for me during this my first time to be in Czech, this very amazing country here. And today I'm talking some very interesting facts about the open source cryptography in China. So I would like to divide my presentation into typically 3 parts. The first one is a very brief introduction to myself and the current status of OpenSSL being used in China. And the second part is I have collected, summarized the 4 very typical cryptography Chinese open source projects. And I will have some brief introduction to them. And the last part will be some future considerations in China, because maybe you guys are familiar with Chinese technical evolution path there. We are doing a really different thing compared to the rest of the world. So there is some facts about me. So my name is Paul Yang, as you know, but that's not my true Chinese name. My Chinese name is called Yang Yang. The first name and the family name are pronounced the same, in the same pronunciation. But as you can see here, that's basically 2 different Chinese characters there. And the first character means the ocean, and the second character means a kind of tree, a plant there. So I started to contribute code to the OpenSSL project. That was back in 2017. And later I was invited to be a committer there for this project. For my work experience, I started my career, that was maybe more than 17 years ago. That was in 2008. I joined a local Chinese software company called NewSoft. And there I started my career doing things like hardware appliance for cybersecurity, like firewalls, UTMs, and ADCs there. And in 2014, I joined Alibaba, the very famous internet giant in China, for cryptography. That was the place all of this story started there. And I started a very small company in the music industry in China in 2020, and that company is called Tongflow. This is the identity I use in the OpenSSL community. So I'm representative of one of the community called small business here. This year in May, I resigned from Alibaba to be created as Ant Group, Alipay, and I joined Lenovo as my daily job. At Lenovo, my primary responsibility there is the privacy computing for the AI boost in China, because we need to not only to protect data in transit and at rest, we need to take data in use protection into consideration. Well, this May, I was elected by the small business community as a member of the corporation TAC. Yes, on behalf of the Tongflow, that small music company there in China. And talking about my contributions to the OpenSSL community all the time, I started writing code and giving feedbacks on code reviews there, firstly. And I have organized a visit of all the, at that time, all the OpenSSL team member. Maybe not all, maybe some of them, maybe 6 or 7% there, just back in 2017. And one of the contributions to OpenSSL, besides the code and the reviews, is something like I extended the use of OpenSSL in China, because what I was doing in the past years is something like propagating this project to the other Chinese people. Yes, and there is also one interesting thing for the cryptography area is strongly connected with different countries and regions regulatory compliance for the country itself. So I have good connections between the Chinese government agency on the cryptography compliance things. Okay, what I'm going to do is, as a new TSC member, is I would like to organize more offline meetups there in China to meet as many as I can the many small business companies in China to collect their requirements for the project. And I think also seeking the things like seeking funds and multi-contributions for Chinese companies, from Chinese developers to the project is also very important. So here comes some facts on the OpenSSL, how it's being used in China. There are several features that are heavily used nowadays in China. The first one is, of course, the TLS 1.3 and the related versions of the TLS protocol there. And the other side of features is I call them conventional cryptography algorithms, which are provided in the lib crypto, like RSA, ECDSA, and blah blah. So the third one is something like we call it commercial cryptography algorithms, which is standardized by Chinese government. The abbreviation for commercial cryptography in Chinese language is called SIM, ciphers there, like SIM234 or something like X.5000 with this kind of algorithms here. And another thing is a little special in China is people, especially like in the small businesses, they are more likely to use the command line tools instead of the library there. They just utilize the tools built from the APP's directory to do their work. As TongFlow, where I work for my personal things there, we just use a lot of these kind of tools to encrypt the file, the recording file, or some songs there made by the customer to protect their user privacy and their data. For the operational systems, there are only 3 kind of them, because you know OpenSSL has supported a lot of different operating systems there. But in China, only 3 of them are very common to use. It's about the Linux at the server side and iOS and Android for the client side. Yep. And for hardware platform, especially for the CPUs, the most common hardware platforms are x86 and ARM. Yeah. Well, the features that are not that popular in China is something like this. The first one is DTLS. I'm not saying that DTLS, the protocol itself, is not popular. I'm saying the library which provides that kind of feature. OpenSSL is not among of that most popular libraries that were used for DTLS, because the DTLS, from my perspective, is a common thing in restricted resource environment like IoT or some other embedding systems there. But OpenSSL is not built for that purpose. So in China, maybe something like embedded TLS or even Wolf SSL are more common there. Yes, that's the Wolf guy from Canada. Thanks for joining. Yeah. And some very rare, to us is something like a little strange algorithms like Blowfish, Camellia, Idea, some other algorithms are also not frequently used in China. And the Quick is another interesting thing is Quick is very common in China, adopted, but it's not for OpenSSL. The reason of this is we were doing that. Our OpenSSL project was doing that too late. That was maybe 7 or 8 years ago, back in 2016. A lot of Chinese internet giants, they started to build their own quick implementations before OpenSSL has dived into this area. So as you can see, this one is called XQuick. It's a library, it's a quick implementation by Alibaba. And you can see just the symbol on the very right of this page. That's the logo of Taobao. It's one of the biggest e-commerce service all over the world. So Taobao is now utilizing XQuick as its fundamental quick implementation. But OpenSSL is also combined to XQuick, but only for the label crypto, for the fundamental, the individual algorithms there, without the network or the protocol things there. Provider mechanism is not quite common in China because there are a lot of hardware vendors for making things like HSMs or acceleration cards there, and they are still using the engine mechanisms here instead of moving to the new provider. Yeah. The other Unix-like systems like VMS or HPUX or IBM IX, that was not popular and common yet. Yes. So the contributions from Chinese developer is more about to support new domestic Chinese CPUs, because nowadays a lot of Chinese CPU vendors, they add instructions, new CPU instructions related to cryptography in the CPU. So as you can see here, maybe for the something like long arc or RISC-V things, a lot of algorithms supported for acceleration for key measurement inside the CPU. Yep. From another market aspect of the status of OpenSSL in China, well, this library is still the most popular one among all of the competitors in China. And from my perspective, it's only because it's open source and free of charge. So you don't need to pay anything for using that. The scenario for Chinese companies by using this library is mostly focused on TLS and the certificate things there. The other things is for the commercial consideration, I'm not aware of there are any paid users in China, so I conclude this as 0. There's no one will pay for this. That's mainly about the culture, because in China, paying for software or paying for support, technical support, is not widely accepted. Yeah. Next one. So we come to the first Chinese cryptography open source project. It's called GMSSL, and GM is just another abbreviation for the Chinese commercial cryptography vocabulary there. So this project was initiated in 2014 by Peking University, one of the top universities in China. The high technical highlights is something like they have supported more comprehensive Chinese SM ciphers algorithms than OpenSSL. And they have replaced the Perl-based build system with CMake to make the things easier than using Perl, because Perl is a really ancient programming language, and nowadays there are few people that can do this. And they have moved to C99 2 years ago, maybe. I consider. And they have also reduced the memory usage and bundle size to put this fork more suitable for embedded environment. And also enhanced security capabilities for well, that's a type of anti-malware and side-channel attacks. Yeah. So the operating status of this project is they gained more than 5.7 kilo stars on GitHub for the past 10 years, and they have 1.8 kilo folks there. Yeah, but unfortunately, this project will be considered as inactive because when I wrote this page of slides, the last commit of that in that repository was last year. The second popular cryptography open source project is called 同锁, which means copper lock. It's just that thing, ancient Chinese lock. It's made of copper lock in China. And this project was forked in 2019 by Ant Group for some very special use. Yes, we forked there based on 1.1.1 at the time, and then moved to 3.0.2 in around 2021. Yeah. And there is a Chinese national open source foundation called OpenItem, and Ant Group has donated this project 同锁 into that foundation in I think it was in 2023 around. So the technical highlights for this project is something like this is the only open source cryptography project that's certified by the Chinese regulation compliance. It's just something like the Chinese version of FIPS 140 in China here. So it now has the security level 1 certificate for a software cryptographic module here. Another thing is in 同锁 we combined the single standalone SMS ciphers with the TLS 1.3. Yep. And another thing we have done is something like we support the coexisting ability with the other OpenSSL versions in one process. I think we have discussed this last week in Brno, right? Guys are considering doing the same things in OpenSSL. Yeah. And TLSP is another modification of Chinese version TLS. They put several things that I can't say into the project, into the protocol designing phase. And many rarely used algorithms are totally removed from this fork. Yes, and many more privacy computing capabilities are added into this project, like ZKP or partial homomorphic encryption algorithms there. Yes, for 同锁 is widely used in many scenarios in different industries, including Alipay, Alibaba Cloud Computing, ByteDance, and they are all big giants, big internet giants in China, and Lenovo and Haigong. Haigong is a domestic CPU vendor of China. They are making their x86 compatible CPUs there. The third one is called Rusty Vault. We started this project in 2023, also by Ant Group. It's a pure Rust written key and secrets management system based on OpenSSL and 同锁. There is effectively is an alternative of the HashiCorp Vault, in case you are familiar with that product. Yeah, doing a lot of key management and secret management in the cloud native area. The tech highlights for this is we have a switchable underlying cryptography library. We can choose to use OpenSSL 同锁 inside or outside China. And we support for the TEE stuff, just like confidential computing. We put some applicabilities and features to do something like a remote attestation service there inside this project. And the work model for this project is either in standalone or work as an SDK. Yep. The last one is from Huawei. They built a brand new cryptography library from scratch. This is not a fork from any other projects there. Just only from zero, right? They have organized a lot of developers doing on this. I don't want to dive into this very detailed information of this because there are a lot of boring things there. So what's the future? There are several trends I consider is very obviously in nowadays China. The first one is PQC. The second one is called confidential computing for protecting data in use by utilizing the TEE, which means trusted execution environment, yeah, providing by CPU. And other privacy computing capabilities like full homomorphic encryption and distance preserving encryption. I have told this, right? Just in the Bruno meetings there, and SMPC. And domestic support for hardware is also required there in China. The last one is the Rust language, which is becoming more and more popular these days. And for PQC, I would like to introduce a program. The Chinese government has established a new institute called the Institute of Commercial Cryptography Standards, and they are calling for submission for cryptography algorithms to the world. So if any of you guys is interested in this area, we are welcome and highly encourage you to submit your proposals there. The exact time for the submission will be, we'll start maybe within this week. So typically there are three categories for the commercial cryptography. So we call it the next generation commercial cryptographic algorithms. So there are three types, maybe NGCC public key algorithms, and NGCC, the C is for cryptography hashing function, maybe something like that. And NGCC BC is a block cipher there. And you need to take into consideration is something like you need to consider the quantum resistant features in those algorithms if you want to submit some proposals there. The transition of to PQC in Chinese markets nowadays, we highly consider it's hard to change it because it costs a lot from migrating the current solutions to adapt to the new ones. That's the first one. And the second one is maybe a little different from the other markets. Is something like we consider software-based solutions will dominate the market instead of using hardware there, like HSMs or some cards, chips there. And the hybrid status will be last for a really long time, maybe the future 10 years or more. Yeah. Second one is confidential computing, just like I said, it's based on TEE and providing one of the ability to protect data in use. And it's becoming very popular due to the AI boost in China, especially for LLM, the large language model inference process. We are adapting that kind of technology in our production environment at a very large scale. And to typical customers of some of the solutions is Nubia. Nubia is one of the famous Chinese smartphone vendor, and the other one is Lenovo. They are just using confidential computing technology in their data centers. Yep. Talking about other privacy computing, technologies, I consider DPE is very important. So I highly suggest if we can find some resources to implement this in OpenSSL for a high performance implementation. That's the one. And SMPC and full HE, full homomorphic encryption with hardware acceleration, and also the PSI nowadays in China are considered important to be used in the privacy computing area. And for the hardware side, Chinese CPUs and other hardware support is also important for cryptographic library. There are just some vendors name here, just like Hagen, RISC-V, which was now developed in the Chinese Academy of Science. Is that name? Yes. Longsan is another chip maker's name. Yes, just something like this. And one thing special is just talked some minutes ago. There are a lot of built-in cryptography instructions inside the CPU. Yep. 4 minutes. Okay, I need to hurry up. So there's no need anymore in the future for Chinese scenarios to depend on additional HSMs. They just put the key measurement, like some key generation or some like of cryptography things inside the CPU. Because if you have a server or you have a device at hand, you must have a CPU installed there. And they built such kind of features inside CPU is very costless and convenient for the users to have the ability of key measurement. Right. Last one is, I think, is the most important thing nowadays, is the Rust language. I had a not formal, but something like a causal search on our OpenSSL repository in GitHub. Just to find there are more than, well, 750 numbers of the pull request we have in the repository that are dealing with null check. There are a lot of review comments addressing that kind of things. Say one pointer, if one pointer equals to null, then you do some error handlings there. Right? A lot of effort were put into that kind of things, which are considered a waste of the development resource only. Yes. So Rust can help with this. So we need to move to Rust rapidly because it's a memory-safe language and it's fast enough for doing low-level things like operating system kernel or cryptography things. And this is an evidence for the Rust language is more used in the cryptography area because Rustos, which is I consider as a competitor to OpenSSL, they are funded just in September by the Rust Foundation. That's all for today. So thank you for listening.
What is the use case for that GMSSL? Like, where would you use it rather than OpenSSL?
GMSSL is created by a university, so it's mainly used in academy scenarios.
Okay.
Yes. So there are a lot of projects between the government and the universities. So that was highly used in that kind of place.
Okay, so it's more of an academic project than a production project.
Absolutely, you are.
Okay, thank you.
And I think we have time for one more question. There's one in the back. He was first, I think. You have a few more minutes. All right.
You mentioned about confidential computing, yes. And I heard that Chinese government is making confidential computing use mandatory. Is it in place? Like, are there real government regulations for this? Is it happening now, or?
Yes, that's kind of right, because the Chinese government, that was in last November, I think, in 2024, there was something like a document printed by the Chinese central government to push the adoption of confidential computing inside China, and they have divided that users into several categories. Like every local government should build a kind of something like a computing center with confidential computing equipped capability there. So I have a report on that, and I can send you later. That report is something for summarizing all the progress during the last year for the confidential computing users in China.
Oh, that would be wonderful. Thank you.
All right, I think we might be out of time. I think we have like literally 4 minutes for the next talk. But if you want to ask the last question, go ahead. And you know,
thank you very much.
we have time for a coffee
You
break.
mentioned expected decline for HSMs in favor of standard CPUs. But for HSM, it's not just they implement particle cryptographic algorithm, but they can also do it in, let's say, physical, more secure way. So do you expect that the CPUs will be able to do it on the similar level as standalone HSMs? Because this is currently not the case.
For security level, I think maybe in the CPU is a little lower than the standalone hardware there, right? But you need to get across that. It's more cost-oriented thing than a security-oriented thing. If the government wants to push the PQC or something like the commercial cryptography in China being more widely used in China in the market, you need to find a very costless way to do that. So HSMs are very expensive now in the market comparing to a CPU. Yeah.